Consider the function. They give us a function there. Enter an antiderivative. Okay, so they want us to come up with an antiderivative. What's that? Well, you know the derivative rules, right? If we have, say, x to the n and we take the derivative of it, derivative of it, let me make that a little bigger. That becomes nx to the n minus 1. You know how that works, right? The n comes down, subtract 1 from the power. There we go. Well, the antiderivative does just the opposite. So if you have x to the n and you do the antiderivative, what is that? You actually add 1 to the power. It's the opposite, right? Anti-opposite. Instead of subtracting 1 from the power, you add 1. And then instead of multiplying by that in the front, you multiply by 1 over it or divide. Same thing. So it's exactly the opposite. Again, instead of subtracting 1 from the power, we add 1. And instead of multiplying by that, we multiply by 1 over that, like that. That's the antiderivative. So that's what they want us to do here. So we take this one, for example, and we make this a little bigger for us. We're going to add 1 to that power. That makes it 9, and then divide by that number, right? Add 1 to that power, divide. 1 over, same thing, divide. There's already a number there. We just divide. 2 nines. That's how they got that. Same thing on the next one. Add 1 to the power. That's how they got that 7, and then divide by that. So that's how they get that 5/7. Next one, same thing. Add 1 to the power. That's how they got that third power. And then divide by that. That's how they got that. Now, the last one's a little tricky. So let me first show you. Think about it. What if we went back the other way? What if we took the derivative? Do you see? So this way, if I took 2/9 x to the 9, just that part, and I took the derivative, what would it be? Well, the 9 would come down. So that would be 2 times 9 over the 9 that's already there. And you subtract 1 from the power, so it'd be 8. These would cancel. It would be 2x to the 8th, which is what it was before. Do you see how the derivative would go right back, which means this is the antiderivative. Because if we take the derivative of it, we get back to 2x to the 8th, which is what we started with. So this is the antiderivative. Same thing if we did this, the 7 would come down, cancel, subtract 1 from the power, go right back to 5x to the 6th. Here the 3 would come down, cancel, subtract 1 from the power, go back to 7x squared. See, so I just want you to see that these terms are the antiderivative. And how we know that is if we took the derivative of them, they would go back. Well, ask yourself this question then. If I took this and I took the derivative of it, what's the derivative of minus 4x? Well, it has a 1 power. So the derivative, what happens? The 1 comes down, minus 4. Subtract 1, so the x is gone, minus 4, right? So that means the derivative of minus 4x is minus 4, which means minus 4x is the antiderivative. Does that make sense? You just think it backwards. When you're doing an antiderivative, you just write something down whose derivative would go back to what you started with. So minus 4x must be the antiderivative, because if I took the derivative of it, it would go back to minus 4. Now, what's up with this plus c out here? Well, that's because you could put any number out here. You could put plus 5, for example. And what if you took the derivative of it? What if you did the derivative? Remember, we're trying to find the anti. This is the antiderivative. All these terms are the opposite derivative, the antiderivative. So that means the derivative of them, like the derivative of minus 4x, will go back to minus 4. Right? If this is the antiderivative, then the derivative of it will go back. Well, I'm saying you could have any number out here, plus that doesn't have an x. Anything without an x, constant number. That's what C stands for constant, meaning it doesn't have a variable, doesn't have an x. Like could be 5. What's the derivative of 5? Well, it'd go back to 0. It just wouldn't even be here. Right. You could have plus 7. What would that do? Same thing. The derivative would go back to 0. Wouldn't even be there. The point is you could have any constant number. That's what that plus c means. You could have any constant number out there, and the derivative would go back because it'd be 0. So the derivative of this term, this term, this term, this term, and any constant number would go back to our original function. Thus, this is the antiderivative. Or we might even say the system of all possible antiderivatives, where that could be any number, 8, 9, 10, 11, 12, etc. There it is. That's the anti. So the plus C, they just put that out there themselves. We didn't type that in. That was already outside the box. And they said, don't put it in the box. Just leave it like that. That's the antiderivative. Just think derivative backwards.